Hello class, and welcome to GIS for Landscape Analysis. I'm Tatiana Swenda. I'll be your instructor this semester. So today I just want to give you a brief introduction into geographic information systems. So what is GIS? GIS, by definition, is a computerized system designed for the storage, retrieval, and analysis of geographically referenced data. GIS uses advanced analytical tools to explore at a scientific level the spatial relationships, patterns, and processes of cultural, biological, demographic, economic, geographic, and physical trends and phenomena. Basically, it's a very sophisticated system that provides us with the ability to analyze the trends and patterns of our existing environment. So G is for the where. Majority of data that we collect, the data that you see on a map, that has a location associated with it. In addition to a location, that data, there's lots of information attached to that data. What we call attribute tables, and we'll get into that. There are many systems, many components working together to achieve a common goal. So if you see the image here, this Google map on an Android, it's a Google traffic app. It's telling you information about your surroundings. Have you ever wondered how that information is collected? Basically, if you have a cell phone, then you are constantly transmitting information about your location. Now, your cell phone provider has sold metadata about you to companies such as Google. Metadata meaning information that is probably just XY coordinates of your location. And so when there is a cluster of these points on a road, and that information is overlaid with perhaps the speed limit of that road, that is how Google traffic apps tell us when there's going to be a congestion. Or sometimes people will upload the fact that there is an accident on a road, and so it becomes a point on the map. So that's an example of a GIS. So we'll be working mostly in this class with geographical features. These are points, lines, polygons on a map that have information attached to them. That is usually information in form of a database table of some sort. So remember, GIS is not just software, and it's not just for making map. It's 5 principal components: the software, data, methods, people, and the hardware. In this class, we'll be using the ESRI ArcGIS platform. There are 3 basic capabilities in GIS that distinguish it from other programs that can generate similar outputs, such as maps. For instance, AutoCAD. You can create maps in AutoCAD. However, it does not have these 3 basic capabilities that GIS does have. One being that the data is spatially referenced. And the way that we're able to do that is through a very scientific process that is map projections. And we use coordinate systems to be able to project our maps. Now, we're not going to be professional cartographers. However, we do need to have a basic understanding of map projections in this course. This is something that we will get a little further into throughout the semester, but basically think of map projections as a way to take a feature, so a polygon that perhaps represents a town or an area of interest, such as a neighborhood, and it's on a curved surface, and somehow overlay that feature onto a flat surface. There's a science behind that, and that is something that digital cartographers have to go to school for many years to understand. So we're not going to really get too much into that, but do understand a little bit about map projections. We'll also be working a lot with coordinate systems and how coordinate systems are measured throughout the globe. When you're dealing with features such as polygons, a map projection is very important. However, when you're dealing with features such as points, an exact point on a map, an XY coordinate, a map projection is not necessarily important. You may not need it, you may not even need to assign a map projection when dealing with just point data. So this is something we'll get a little bit into further into the semester. The second basic capability of GIS is that spatial data layers can be overlaid, manipulated, and combined to form composite layers. This is a very powerful function of GIS. So let's first begin by talking. Spatial data is data which covers multidimensional points, lines, rectangles, polygons, cubes, and other geometric objects, often referred to as layers. We will refer to spatial data in our course as layers. Now, there are three basic types of spatial data that we will be using. There is vector data, which is a primary type of data that we'll be working with in the semester. And that's basically points, lines, polygons, and tins. Secondly, there is raster data. That's when data is represented as a rectangular matrix of square cells. And finally, there is tabular attribute table data, which is basically like an Excel spreadsheet that is attached to each feature on a map. So layers represent in a special digital format features on, above, or below the surface of the Earth. Vector data uses points and their XY coordinates and associated attribute data to represent spatial features or objects. Vector data uses points and their XY coordinates and associated attribute data to represent spatial features or objects that are on, above, or below the surface of the Earth. We represent vector data as lines on a map to represent roads or power lines. Each line is stored by the sequence of the first and last point together with associated table attribute of this line. So for instance, if this diagram on the left here is line that represents power lines, then the attribute for each segment, so as you see, there is A to B, that's segment A, and then there's this node to this node, that's segment B, and this node or point to this point, that's segment C. So there is associated information in an attribute table about each one of those segments. So that could be capacity, flow, whatever information that there may be attached to that type of data. We also represent data as points, and each point is stored by its location, XY coordinate, together with its attribute for this point. So if the point is a building, then it would have perhaps a type of building, height, and vector data is also represented as polygons, which is a sequence of lines that is closed. So for instance, a lake would be represented on the map as a polygon, or a city or a neighborhood, and the types of attributes in that table would be perhaps the total area or the population of that area, of that neighborhood. And finally, we represent vector data as tins. This is where we are able to create 3D surface models of our environment. tint or triangulated irregular network is a vector-based representation of the physical land surface or sea bottom. The basic unit is a triangle used for surface modeling. We won't get too much into raster data in this semester, but do know what raster data is. It's basically when you represent the world as a grid of square cells, the center of that cell will have an attribute. This is often used for slope analysis and terrain analysis, where each grid represents an elevation value. And so you're able to determine perhaps what the slope is, and where, if you're designing perhaps a ramp or a walkway of some sort, you'll know where you'll need to have some sort of intervention if the slope does not meet design requirements naturally. So all of these types of spatial data, which we refer to as spatial data layers, vector and raster and the attributes that are attached to it, can be overlaid and manipulated using GIS. Overlay analysis is a major part of GIS analysis. So for instance, if we want to take all of our spatial data layers to conduct an overlay analysis to perhaps study a crop yield, you would overlay layers to create a composite layer. So for instance, this farmer wanted to find out where there would likely be low, medium, or high crop yield for his or her land. And so they compared the salinity of water with incidence of disease, perhaps it's either disease in vegetation or water, with the water quality. And they were able to, using their own formulas for what happens when certain attributes of these features come together, to generate a map that tells us where you're going to have low, medium, and high likeliness of a crop yield. The third capability of GIS is that spatial features are linked to tabular data using relational database. This is an example of spatial features tabular data. We're looking at a map that is showing all of the crime incidents that occurred between 2010 and 2015. Each point of that map has an attribute table, a spreadsheet, with a record that relates to that particular point on the map. So let's take a closer look at that database table. Database tables in our course we will refer to primarily as attribute tables. So an attribute table consists of a record for each feature on the map, a field, or actually multiple fields representing attributes of each feature on the map. So each point, each line, each polygon, each raster grid cell, and records, which are the actual information or the attributes within the field. Now this allows us to conduct compound attribute queries. Compound attribute queries are very helpful when we're trying to extract information from a map. So for instance, if we want to know where all the drug-related calls are after a certain date, we would do something called a query. That's basically asking the map a question. So the map on the left is showing all of the crimes from 2010 to 2015 within this neighborhood, and the map on the right is showing you where are all the drug crimes from 2012. So as you can imagine, this type of system is useful to many different types of businesses, because the nature of most organization is that you get and you manage information, you analyze that information, and you create or recreate some kind of good or service. GIS technology allows you to manage that geospatial information, very, very large quantities of geospatial information. Using attribute queries and many other tools that we'll get into the semester, where we can easily analyze geospatial information. And as a result, we're able to put together geospatial design. GIS is actually the precursor for an emerging field of study called geodesign. So GIS is used in many different industries, from business, defense, education, government, natural resources, mapping and charting, health and human services, public safety, transportation, utility and communications. I actually work for a urban planning and consulting firm, and GIS is the backbone of our department. We would not be able to make the many millions that we make every year without having GIS as a tool. There's always a process involved with working on a GIS project, and it's common to what we refer to as end-to-end map-making process. We begin by defining a problem. We then define the GIS criteria to solve that problem. We import and build data sets of information. We overlay those layers of information and conduct GIS analysis. We generate an output and we make a decision based on that process. Have we solved our problem? If not, then we refine the problem and start the process again. Here's an example of a GIS process that is currently underway in Los Angeles. So in 2005, city officials in Los Angeles, California, launched a major public works project focused on human dimensions of the river. There was a landmark study that demonstrated the significant potential to improve quality of life for citizens living near the river corridor through wise redevelopment. So their goal was to create pocket parks and landscape walkways to create places where children can play and adults can stroll. So here's an example of the process that the GIS analysts involved in this project took to find the most optimal locations for this corridor for healthy living. So they began with mapping out where the river was. They then created a proximity zone, a tool that we call the buffer tool, that is within a certain distance of the river, of where they want to target to start greening its surroundings. Based on those proximity zones, they created other proximity zones around existing parks. So they took those two buffer zones and subtracted them from each other, and that's how they identified this is exactly where we want to work. This is where we are within a certain distance of the river, and we also are not within an existing park. They added boundaries that represent census boundary. Basically, it's boundaries that have information about the population, such as how many people, what are their ages, what is the average income or median income, and all that sorts of information, and collected that information of the census blocks that are within their desired target areas. So they had a very detailed list of criteria for the people. And so the third step was to designate of that buffer zone, or of that area that they want to build more parks, where is the population more favorable or less favorable? Where are we likely going, is this park likely going to get the most use based on that population? And then the second part was to overlay municipal data, so city data about property ownership. And that is what we called parcels. Parcels are polygons that represent ownership of an area. So they took parcels that are vacant, and they tagged those as their priority parcels. They selected all of those priority parcels and the population immediately surrounding those priority parcels. And they were able to come up with a map that showed the most optimal locations within this corridor to build their next park. GIS is also a very important tool in landscape design and landscape analysis. So landscape architects in this course, this is something that I strongly recommend that you take this course very seriously. It's a very important part of your field of study. The GIS is a great tool to help you understand the context. How does it operate? Is it working well or not? What is the process that we can take that might alter the context? And what differences might the changes cause, and how should the context be changed? As I mentioned earlier, there is an emerging new field of study called geodesign. The director of the program is a very respected professor here at Philadelphia University. He is a professor in the landscape architecture program, Jim Query. And this is his quote, "The future of design excellence and sustainability across the design disciplines will require ever-increasing complex problem-solving skills to empower creativity." So geodesign is basically smart design. It's taking information that we learn from different types of GIS analysis and processes and making smart decisions. So again, GIS is a very important tool for the analysis of our existing environment. It's used in many fields of study, in many industries, and it's something that is a precursor to a new field of study called geodesign. So this concludes our introduction to GIS for landscape analysis. I will be sending you a list of questions and instructions on how I would like you to answer those questions.